Other charge species that exist in chemistry are polyatomic ions, and they are a group of atoms with an overall charge consisting of nonmetals like phosphorus, sulfur, carbon or nitrogen, and oxygen coming together. Out of the polyatomic ions, which ones do you need to know? The ones that are given in the following slide. You need to know for them their chemical formula, which is given in the following columns. You need to know their overall charge, which is symbolized by the superscript that is in the top right corner by the chemical formula. And you also need to know the name of the ion. So just memorize the first word, not the word ion, because overall we know that these are polyatomic ions and we need this information when we are characterizing or naming a chemical formula. So now in section 3.3, we are going to learn how to take ionic compounds and understand how electrons are given and taken. It is important that if you're given a pair of elements that you know how do they form these ionic compounds. The rules of how to write the chemical formulas for ionic compounds are given in steps 1, 2, 3, and 4. I'm going to have some examples to illustrate the steps. As you can see, we're going to write the symbol of the metal cation and its charge. Here we have magnesium. Magnesium has a symbol of Mg, a charge of +2 or 2 plus, whichever way you try to do it, but writing +2 or 2 positive, same thing. Bromine has a charge of -1. If you need to review, how do I know these charges? Remember that these are representative elements. And in this chart, it is illustrated that depending on your group number, what's going to be the charge for that element. So, taking that into consideration, so I did step 2, write the symbol for the nonmetal and its charge. Then I'm going to take the charge, which is going to be the value of 2 or the value of 1, and that is going to become the subscript of the other atom. Subscripts are going to be written at the bottom right corner of the element symbol. So at first, we're going to write Mg1Br2. Understand that once you do that process, a value of 1 is always omitted. So even though at first we have Mg1Br2, we are going to delete the 1. And our final answer is Mg-Br2. Let's go to the second example, calcium and oxygen. Calcium lives in group 2A, so it's going to be a charge of +2. Oxygen is going to have a charge of -2 because it lives in group 6A. So when we go to the same process of the charge becomes the subscript of the next one, we may write in Ca2O2. But notice rule number 4. If you see that the subscripts that you just assigned are divisible by one another, you need to make sure that they're converted to the smallest whole number ratio. So if you divide both sides by 2, you're going to say Ca1O1, and because the 1 is omitted, then the final answer is CaO. A quicker way to do this is that if you see that the charge of your cation is going to be the opposite of the same charge that you see on the anion, as you can see here, we have Ca2 plus. It will cancel with the O2 minus. Then you just write the symbols. CaO. Let's do one last example. What if we're doing a process in which I have a variable charge element, like I see iron? You can see here how the Roman numeral will tell you what's going to be the charge on the iron. That's the key to know that you have a variable charge ion, that you have the name of the element, and in parentheses you see a Roman numeral. So I'm talking about iron, which lives in group B, but because it has a Roman numeral of 3, then this is going to be iron 3 plus. Carbonate is in the list of my polyatomic ions, which is CO3 2 negative. We go through the same process. I wrote my cation and its charge, the anion and its charge. Then I'm going to take the value and make it the subscript, okay, of the other atom or group of atoms. So at first I'm going to write Fe2CO3, but then I also have to write a 3. And if you look to the right side, that chemical formula, it looks kind of weird because you have 3 and 3. How do we solve that problem? Whenever you have a polyatomic ion and it has a subscript of 2 or more, we're going to wrap it in a blanket. We're going to put it over parentheses to solve that issue. So the correct formula for the third problem is as follows. Let's practice. For this, I'm going to do letter C and letter E. Here I have manganese, symbol Mn. The Roman numeral 4 tells me that I have Mn4 plus. I have oxygen. Oxygen lives in 6A. It has a charge of 2 negative. So when I do the exchange in the numbers, Mn2O4, I notice that the 2 and the 4 are divisible by one another. So my final answer is MnO2, because I have to make sure that my subscripts have the smallest whole number ratio. Let's look at letter E. In letter E, I have 2 polyatomic ions. That's why it's important that you practice and you go through the tables. Ammonium, NH4, positive 1. Phosphate, PO4, negative 3. So when I exchange the 3, that's the subscript of the NH4, the 1, that's the subscript of the phosphate, I'm going to write NH4, 3, but because, again, it received the subscript of 2 or more, we need to put the polyatomic ion in a blanket. Phosphate is going to get a subscript of 1, so we just write PO4, because when you have a subscript of 1, you don't need parentheses, because the 1 is anyways omitted. Make sure that you practice how to go from a pair of elements to write the chemical formula for a particular compound. You guys also have to be able to go from, if I'm given the chemical formula, how can I write the name? And as you can see in the slide, we have the different rules for how to name ionic compounds. As you can see, you're going to identify the cation and the anion in the chemical formula. And then we have a set of rules for the cations in steps 2 and 3. And then a set of rules for just anions that are nonmetals in step number 4. If you have polyatomic ions, then rule number 5 is applied. Let's actually practice a few problems to understand these rules. So, in order to understand this, I'm going to do letter A, letter D, and letter F. In letter A, we have sodium and bromine. Sodium and bromine, they're both representative elements. So in the case of sodium, because it is a representative element in group 1A, I'm just going to use the name of the element. So I'm going to write sodium. This is given, as you can see, by rule 2. Then you can see that in rule 4 for my anion, I need to use the names that are given here for when I have the anion for any of these elements that form a negative charge that are going to be representative elements from groups 5A, 6A, and 7A. So since bromine comes there and bromine is going to form an anion, when bromine forms an anion, it's called a bromide ion. So the name of this compound is sodium bromide. If we look at example D, I have a metal of multiple charge, nickel, and I know that it is a metal of multiple charge because it lives in group B, and I'm pairing it with a nonmetal, chlorine. As you can see, to name something from group B, okay, you need to break the chemical formula into ions. So nickel is going to be positive 3. Chlorine is going to be negative 1. The reason why I know that that is the case is because remember, this subscript was obtained because nickel gave it to chlorine. Chlorine is going to get a negative 1 because you can see that the 1 that used to be by nickel is omitted. And we always write chemical formulas as cations followed by anions. Then, now that I broke this into ions, then I'm going to proceed to name this compound. As you can see in rule number 3, for when I have elements that live in group B, I'm going to use the name of the element followed by a Roman numeral in parentheses to indicate its charge. So for this, I'm going to say nickel. The charge is 3. And then how do I get the name for the Cl minus? Is going to be rule number 4. I look for Cl minus, that is called a chloride. So the name of this compound is nickel 3 chloride. Lastly, I also have a nickel compound, okay? And in this nickel compound now is paired with something that is in parentheses. And if you're familiar with those tables, you will see that NO3 is actually nitrate. And when it comes to nitrate, because in here we have specifically a metal that lives in group B, we need to break this into ions. This is Ni plus 2 plus NO3 minus 1. For those of you that are like, where are you getting this plus 2, plus 3? Pay attention to the chemical formula because that's where you're going to see it. This 2 outside the parentheses of the nitrate used to be what the charge of nickel was. The one that is omitted right here is the charge that used to be at the nitrate. And remember that the first element makes a cation. The second element or group of elements makes an anion. So that's where I got those charges. So in example F, nickel, since it has variable charge, rule number 3 tells me that I need to write the name of the element. And then in parentheses, the Roman numeral. Then after that, For rule number 5, in this case, we have a polyatomic anion because it's negatively charged. We're just going to use the name of the ion, which is nitrate. So the name of this compound is nickel 2 nitrate.